The world you see on a map is a simplified version of something far more complex. Beneath coastlines and borders, systems are constantly interacting, often in ways that aren't obvious unless you know where to look. Entire regions behave differently not because of chance, but because of deep geological history, atmospheric patterns, and long-term processes that rarely get explained in detail. What makes geography truly interesting isn't memorizing names. It's understanding why something exists exactly where it does, and why it behaves the way it does over time. Some of these facts are subtle, others reshape how you think about entire continents. Stay with this carefully, because once these patterns click, the world starts to feel less random and a lot more connected. In the city of La Paz in Bolivia sits at such a high altitude that water boils at around 87 degrees Celsius instead of 100. At roughly 3,650 meters above sea level, the atmospheric pressure is significantly lower than at sea level, which reduces the boiling point of liquids. This affects everything from cooking times to industrial processes, forcing locals to adapt their daily routines. It also means engines perform differently because combustion behaves differently in thinner air. Over time, people living there develop physiological adaptations, such as increased red blood cell counts, allowing them to function normally where others would struggle. There is a place in the Atlantic Ocean where compasses can point to true north instead of magnetic north. This area, known as the agonic line, shifts over time as Earth's magnetic field changes. Unlike the geographic North Pole, the magnetic North Pole constantly moves due to fluid motion in Earth's outer core. At certain points along this line, the difference between magnetic and true north becomes zero, creating a rare alignment. This phenomenon is important for navigation systems, especially before GPS technology became standard. Even today, pilots in maritime navigation charts must constantly adjust for this shifting magnetic variation. The island of Socotra, part of Yemen, has plant life that looks almost alien because of its long geographic isolation. Around 1/3 of its plant species are found nowhere else on Earth, including the famous dragon's blood tree, which produces a deep red resin. The island's isolation in the Arabian Sea, combined with its unique climate of intense sun and seasonal monsoon winds, which created evolutionary pathways rarely seen elsewhere. Its ecosystem developed with minimal outside influence for millions of years. This makes Socotra one of the most biologically distinct places on the planet, often compared to a natural laboratory of evolution. In Namibia, there is a coastal desert where sand dunes meet the ocean directly, creating one of the sharpest environmental contrasts on Earth. The Namib Desert runs along the Atlantic coastline, where cold ocean currents limit rainfall, while fog provides the main source of moisture. Some dunes rise over 300 meters high and have remained stable for thousands of years due to consistent wind patterns. The interaction between ocean air and desert heat creates unique microclimates that support specialized forms of life. This region demonstrates how ocean currents can completely reshape the climate of adjacent land. There is a town in Canada, Churchill in Manitoba, where polar bears regularly walk through the streets. This happens because the town lies directly along the migration route of polar bears moving toward Hudson Bay. When the bay freezes, bears head out onto the ice to hunt seals, but before that, they often pass through the town. Local infrastructure is adapted to this, including designated safe zones and even a polar bear jail where problem animals are temporarily held. The phenomenon is entirely tied to seasonal sea ice formation in the geography of the bay. It's one of the few places where human settlement directly overlaps with large predator migration patterns. The Caspian Sea is called a sea, but it is technically the largest lake in the world. It is landlocked and has no direct connection to the global ocean, which classifies it as a lake despite its massive size of about 371,000 square kilometers. Its salinity varies significantly across different regions, from almost fresh water in the north to much saltier conditions in the south. This variation is caused by river inflow, especially from the Volga River, combined with limited evaporation zones. The Caspian also sits below sea level and contains significant oil and gas reserves, making it both a geographic and economic anomaly. There is a region in Venezuela where lightning strikes almost continuously for months at a time. Known as the Catatumbo lightning phenomenon, it occurs near Lake Maracaibo and can produce lightning for up to 10 hours per night. The geography of the surrounding mountains funnels warm, moist air into the region, where it collides with cooler air masses. This creates highly stable storm conditions that regenerate nightly. Scientists estimate that this area experiences over 200 lightning flashes per square kilometer each year. It is considered one of the most consistent natural lightning generators on Earth. The country of Lesotho is entirely above 1,000 meters in elevation, making it the only nation in the world with that distinction. Located within South Africa, its mountainous terrain influences everything from climate to agriculture. Winters can bring snow, which is unusual for southern Africa. The elevation also limits certain types of infrastructure and farming, while supporting others like highland grazing. Rivers originating in Lesotho are crucial water sources for surrounding regions, including major South African cities. Its geography plays a direct role in regional water supply systems. There is a massive underwater waterfall in the Denmark Strait between Greenland and Iceland. It is driven by differences in water temperature and density, where colder, denser water from the Arctic sinks beneath warmer Atlantic water. This creates a downward flow reaching depths of over 3,500 meters. Although invisible from the surface, it is the largest waterfall on Earth by volume. The process is part of global ocean circulation systems that regulate climate. Without these deep water flows, heat distribution across the planet would change significantly. In China, the Loess Plateau contains some of the most fertile soil on Earth, yet it was once heavily eroded and degraded. The fine, wind-blown sediment called loess can be dozens of meters thick and is extremely easy to cultivate. However, its loose structure also makes it vulnerable to erosion when vegetation is removed. Large-scale restoration efforts in recent decades have transformed the region through terracing and reforestation. This has reduced sediment flow into the Yellow River and improved agricultural productivity. It's one of the largest examples of human-driven landscape recovery. There is a place in Ethiopia called the Danakil Depression, where the average annual temperature is among the highest recorded on Earth. Some areas consistently exceed 34 degrees Celsius year-round, with daytime peaks much higher. Here, the region sits below sea level and is located at a tectonic triple junction where three plates are pulling apart. This creates volcanic activity, salt flats, and acidic hot springs with extreme chemical compositions. Despite the harsh conditions, people live there and mine salt using traditional methods. It's one of the most geologically active and extreme environments accessible to humans. The border between Spain and Portugal includes a tiny uninhabited island that technically changes sovereignty every 6 months. Known as Pheasant Island, it sits in the Bidasoa River and is governed jointly by both countries. Control alternates twice a year under an agreement that dates back centuries. This makes it one of the smallest shared territories in the world. The arrangement reflects historical treaties and shows how geography can produce unique political solutions. In Siberia, there are craters forming in the ground due to thawing permafrost releasing methane gas. These explosions occur when gas builds up beneath frozen soil and suddenly erupts. Some craters can be tens of meters wide and deep, appearing almost overnight. This is directly linked to rising temperatures and changes in Arctic climate systems. The process highlights how frozen landscapes can become unstable when long-term temperature balances shift. It also raises concerns about large-scale methane release, which is a potent greenhouse gas. The city of Dubai sources most of its drinking water from desalination plants. With very limited natural freshwater resources, it converts seawater into potable water using energy-intensive processes. This allows large-scale urban development in an otherwise arid desert environment. However, it also creates environmental challenges, including high energy consumption and salt discharge back into the sea. The city's growth is directly tied to technological solutions, overcoming geographic limitations. Without desalination, its population density would not be sustainable. There is a region in Kazakhstan where entire villages were relocated due to shifting sand dunes. The movement of sand, driven by wind patterns and vegetation loss, can gradually bury infrastructure. This process can take years or decades, but once it reaches settlements, relocation becomes necessary. Efforts to stabilize dunes often involve planting vegetation to anchor the sand. The situation shows how landscapes that appear static can actually be in slow motion. The Great Lakes in North America contain about 21% of the world's surface freshwater. Their combined volume is over 22,000 cubic kilometers. These lakes were formed by retreating glaciers at the end of the last ice age, which carved out massive basins. They influence regional climate by moderating temperatures and generating lake-effect snow. Their size is so large that they behave more like inland seas than typical lakes. There is a place in Australia called Lake Hillier that appears bright pink due to microorganisms and salt concentration. The color remains stable even when water is removed from the lake. The exact combination of algae and bacteria creates pigments that produce the distinctive color. Despite its unusual appearance, the water is not toxic to humans. This is an example of how chemical and biological factors can dramatically alter natural landscapes. The Strait of Gibraltar acts as a gateway between the Atlantic Ocean and the Mediterranean Sea, controlling water exchange between them. Because the Mediterranean loses more water through evaporation than it gains from rivers, denser salty water flows out at depth, while fresher Atlantic water flows in at the surface. This constant exchange maintains the sea's balance. If the strait were closed, the Mediterranean would gradually evaporate again. The entire system depends on a narrow passage only about 14 kilometers wide at its narrowest point. In Argentina, there is a glacier called Perito Moreno that is one of the few in the world still advancing. Most glaciers are retreating due to rising global temperatures, but this one remains stable or grows slightly. Its behavior is linked to unique local climate conditions and ice dynamics. Periodically, it blocks a water channel, creating pressure that eventually causes dramatic ice ruptures. These events can release huge volumes of water in a matter of hours. The country of Nepal contains 8 of the world's 14 highest mountains, including Mount Everest. This concentration is due to the ongoing collision between tectonic plates. The region continues to experience earthquakes as stress builds and releases along fault lines. These geological processes not only create mountains, but also shape river systems and climate patterns across South Asia. In the Pacific Ocean, there is a massive region known as the Point Nemo, with the oceanic pole of inaccessibility, which is the farthest point from any land on Earth. It sits roughly 2,688 kilometers away from the nearest coastline in any direction, making it more isolated than most places humans have ever visited. Because of this extreme remoteness, it is often used as a spacecraft cemetery, where decommissioned satellites are directed to crash safely into the ocean. The surrounding waters are biologically sparse due to limited nutrient flow, which reduces marine life density compared to other ocean regions. Even astronauts aboard the International Space Station are sometimes closer to Point Nemo than any human on land when passing overhead. There is a river in Antarctica that flows red like blood, known as Blood Falls. The color comes from iron-rich water that oxidizes when it reaches the surface, creating a rust-like appearance. The water originates from a subglacial lake trapped beneath the ice for millions of years, completely isolated from sunlight and oxygen. Despite these extreme conditions, microbial life exists within this system, surviving on chemical reactions instead of photosynthesis. This discovery has influenced how scientists think about the possibility of life on other planets with similar environments. The country of Chile is so long and narrow that it spans multiple climate zones from north to south. It stretches over 4,300 kilometers in length, but averages only about 177 kilometers in width. This means you can move from one of the driest deserts in the world, the Atacama, to cold glacial regions in Patagonia within the same country. The Andes Mountains run along its eastern edge, creating a natural barrier that shapes weather patterns. This geographic structure forces Chile to manage a wide range of environmental conditions within a relatively narrow territory. Beneath the Sahara Desert, there is a massive underground water reserve known as the Nubian Sandstone Aquifer System. It holds an estimated 150,000 cubic kilometers of fossil water, accumulated thousands of years ago when the region was much wetter. This water does not replenish on human timescales, making it effectively non-renewable. Several countries rely on it for agriculture and drinking water, especially in areas where rainfall is extremely limited. The existence of this aquifer reveals that today's deserts often sit on top of ancient, very different climates. There is a place in India called Mawsynram that receives more rainfall than almost anywhere else on Earth. It averages over 11,800 millimeters of rain per year, driven by monsoon winds that carry moisture from the Bay of Bengal. The surrounding hills force the air upward, causing it to cool and release large amounts of precipitation. This orographic effect creates intense and consistent rainfall patterns. Local architecture and daily life are adapted to handle nearly constant wet conditions. The borders of many African countries are unusually straight because they were drawn during colonial times without regard for natural geography. European powers divided the continent using latitude and longitude lines rather than rivers or mountain ranges. This created borders that cut across ethnic and ecological regions, and leading to long-term political and social challenges. Unlike borders shaped by natural features, these artificial lines do not reflect the landscape. As a result, many countries contain diverse groups that were not historically unified. The Mississippi River has changed course many times over thousands of years, reshaping the landscape of the United States. Rivers naturally meander, but the Mississippi is particularly dynamic due to its size and sediment load. Engineers have built control structures to prevent it from switching to a shorter path toward the Gulf of Mexico via the Atchafalaya River. If that shift occurred, it would drastically impact cities like New Orleans and major shipping routes. This is an example of humans actively trying to control a natural system that constantly seeks equilibrium. There is a region in the Pacific called the Coral Triangle that contains the highest marine biodiversity on Earth. It spans parts of Indonesia, the Philippines, Malaysia, Papua New Guinea, and surrounding areas. Over 500 species of reef-building corals are found there, compared to about 50 in the Caribbean. Warm waters, complex coastlines, and nutrient flows create ideal conditions for marine ecosystems. This region supports millions of people through fishing and tourism, making it both ecologically and economically critical. In Greenland, melting ice is actually slowing down the local rotation of the Earth slightly. As ice mass redistributes into the ocean, it changes the planet's moment of inertia. This causes small variations in Earth's rotation speed and axis. While the effect is minimal, it is measurable with modern instruments. And these changes also influence sea level distribution globally, not just near Greenland. It shows how large-scale geographic processes can impact planetary physics. There is a village in Norway called Rjukan that receives almost no direct sunlight for half the year. Surrounded by steep mountains, the sun stays below the horizon from September to March. To compensate, large mirrors were installed on nearby mountains to reflect sunlight into the town square. This engineering solution demonstrates how geography can directly affect human lifestyle and infrastructure. The town's layout and daily routines are shaped by its position within a deep valley. The Baltic Sea is one of the least salty seas in the world due to limited exchange with the ocean and significant freshwater input. Rivers flowing into it dilute the salinity, creating brackish water conditions. This unique balance affects which species can survive there, as it is neither fully marine nor freshwater. It also influences freezing patterns in winter, as lower salinity allows ice to form more easily. The sea's geography restricts water circulation, making it particularly sensitive to pollution. There is a massive sand sea in China called the Taklamakan Desert, where entire ancient cities have been buried. Located along the historic Silk Road, shifting dunes gradually covered settlements as trade routes change. The desert is surrounded by mountains that block moisture, creating extremely dry conditions. Archaeological remains preserved under sand provide insights into ancient civilizations. This demonstrates how changing geography can erase human activity over time. The Great Rift Valley in East Africa is a tectonic feature that is slowly splitting the continent apart. It stretches over 6,000 kilometers from the Middle East down to Mozambique. Over millions of years, this rifting process could create a new ocean basin. The region is also home to many lakes, volcanoes, and geothermal features. It represents an early stage of continental breakup, a process that has shaped Earth's surface repeatedly. In the Netherlands, about 1/3 of the country lies below sea level. Extensive systems of dikes, pumps, and barriers are used to prevent flooding. Land has even been reclaimed from the sea through a process called poldering. Without these engineered defenses, large parts of the country would be underwater. This makes the Netherlands one of the most heavily managed landscapes in the world. The city of Mexico City is sinking at a rate of up to 50 centimeters per year in some areas. It was built on an ancient lake bed, and excessive groundwater extraction is causing the ground to compact. This leads to uneven sinking, damaging buildings and infrastructure. The process is difficult to reverse because the original lake system no longer exists. It shows how urban development can interact with underlying geology in unexpected ways. There is a lake beneath the ice in Antarctica called Lake Vostok that has been sealed off for millions of years. It lies about 4 kilometers below the surface and is kept liquid by geothermal heat. Scientists believe it may contain unique microbial life adapted to extreme conditions. Studying it provides insight into isolated ecosystems and potential extraterrestrial environments. The lake is one of the largest subglacial lakes discovered. The Amazon rainforest generates much of its own rainfall through a process called evapotranspiration. Trees release water vapor into the atmosphere, which contributes to cloud formation and precipitation. This creates a self-sustaining cycle that maintains the forest climate. If large areas are deforested, this cycle weakens, potentially reducing rainfall. The system is a key component of regional and even global climate regulation. The island of Surtsey near Iceland was formed entirely by volcanic activity in 1963. It emerged from the ocean during an eruption and has been studied ever since as a natural experiment in ecological succession. Scientists have observed how life gradually colonizes new land, starting with microbes and eventually plants and animals. So human access is restricted to preserve its natural development. It offers a rare look at how ecosystems begin from scratch. There is a region in Turkmenistan known as the Door to Hell, a burning natural gas crater that has been on fire since 1971. It was accidentally ignited during a drilling operation to prevent methane release. The fire has continued for decades due to the constant supply of gas beneath it. The crater is about 70 meters wide and glows continuously. It highlights how geological resources can interact unpredictably with human activity. The Himalayas influence weather patterns far beyond their immediate region. They block cold air from Central Asia, helping to create warmer conditions in South Asia. They also force moist air upward, contributing to monsoon rainfall. Without this mountain barrier, climate across the region would be drastically different. This makes them a major factor in the distribution of agriculture and population. There is a river in Colombia called Caño Cristales that appears to change color throughout the year. Its vivid reds, yellows, and greens come from aquatic plants that respond to seasonal water levels and sunlight. The effect only occurs under specific conditions, making it a temporary natural display. The river's location in a remote region has helped preserve its clarity. It is often described as one of the most visually unique rivers on Earth. The Arctic Ocean is the smallest and shallowest of the world's oceans. Its average depth is about 1,000 meters, compared to over 3,700 meters for the Atlantic. Large portions are covered by sea ice for much of the year. This influences global climate by reflecting sunlight and regulating temperature. Changes in Arctic ice coverage have significant effects on weather patterns worldwide. There is a phenomenon called isostatic rebound, where land rises after being freed from the weight of ice sheets. This is happening in parts of Canada and Scandinavia following the last ice age. The land can rise by several millimeters per year, slowly altering coastlines. In some areas, former seafloors are now exposed as land. This process continues thousands of years after the ice melts. The Strait of Malacca is one of the busiest shipping routes in the world. It connects the Indian Ocean with the South China Sea and handles a significant portion of global trade. Its narrow width, at points less than 3 kilometers, makes it strategically critical. Any disruption there can affect international supply chains. Geography in this case directly shapes global economics. There is a massive plateau in Tibet often called the roof of the world. It averages over 4,500 meters in elevation and influences atmospheric circulation across Asia. Its height affects wind patterns and contributes to monsoon formation. The plateau also stores large amounts of fresh water in glaciers. These feed major rivers that support billions of people downstream. The Okavango Delta in Botswana is one of the few inland deltas in the world. Instead of flowing into the ocean, the river spreads out into the desert and evaporates. Seasonal flooding creates a rich ecosystem in an otherwise dry region. This unusual drainage pattern supports diverse wildlife. It demonstrates how water systems do not always follow expected paths. The country of Indonesia sits on thousands of islands formed by volcanic activity. It has over 130 active volcanoes, more than any other country. This results from its position along multiple tectonic boundaries. Volcanic soils are highly fertile, supporting dense populations. However, this also makes the region prone to eruptions and earthquakes. The Andes Mountains create a rain shadow effect that contributes to the dryness of the Atacama Desert. Moist air from the Amazon basin rises and loses its moisture before crossing the mountains. By the time it reaches the western side, little moisture remains. This creates one of the driest environments on Earth. Mountain ranges often act as climate barriers in this way. There is a region in Siberia where the ground remains frozen year-round, known as permafrost. In some areas, it extends hundreds of meters deep. This frozen ground traps organic material and gases like methane. When it thaws, it can release these gases and destabilize the surface. Infrastructure built on permafrost must account for this instability. The Panama Canal cuts through Central America, connecting the Atlantic and Pacific Oceans. It uses a system of locks to raise and lower ships across varying elevations. This reduces travel distance by thousands of kilometers compared to sailing around South America. Its construction required massive engineering efforts and reshaped global trade routes. The canal remains one of the most important man-made geographic features in the world. Be curious and always seek to learn something new. Subscribe and see for yourself. Thanks for watching.